Hey everybody, so we are looking at this problem reverse bits. We need to reverse the bits of an unsigned integer. So we are given something like this. This is an integer value and this is the binary representation of that value. We need to reverse the bits, which means if you look from here, this is 0, 0 and 1 and that is shifted to over here 0, 0 is and 1. It's like reading from the right, and we need to reverse these bits and we need to return the integer value of those bits. Basically, we have to return the decimal value of these binary numbers. So to solve this problem, let's take a smaller example. Let's take 1011. Let's assume we have this. So to make it 1101, we have to find a way to extract this one and put it over here. We have to find a way to extract this one and put it over here. Let's say I want to extract this one. What can I do? Let's take this number and I can AND this number with 1. If I do this, I would get a 1 over here. What if this was 0? This would give me a 0 over here, which means when we perform an AND operation with 1, we would get the value at this position. So we know how to extract this. Next, how do we extract this value? So to do that, we can shift this input. We can shift it by 1 on the right. So it becomes 101. This one is gone. And we can do AND of 1 again. And that gives us a 1 again. But now I am able to extract these values. How do I put it in the result? In the result, you can see the value that got extracted first is on the left, and then the second value, and then the third value, and so on. And that we can achieve by the left shift operator. This one extracted over here would be shifted to the left, and we would add the new element, the new binary number over here. So let's take an example. I have this number 1011. Let's AND it by 1. This would give me a 1. Let's right shift the input, left shift the result. I have something like 101 and with 1. My input, my result becomes 1 0. My result becomes 1 0. And over here I get a 1. I add these two, which means I can perform a bitwise OR operation, which means this becomes 1 and 1. This would be my result. I can right shift this, I can left shift this. This becomes 1 0. And with 1, my result over here is 1 1 0. Or with over here, I get a 0. So my result becomes 1 1 0. Now right shift this again, left shift this again. It becomes 1 and 1. I get a 1 here. My result was 1 1 0 0. I perform an OR operation and I get 1 1 0 and 1. So what are the different parts of this algorithm? First of all, I have this logic to extract the last element, the right shift operator, the left shift operator, the one on the input, the one on the output, and I need to perform this OR to add these results. Now, these are the basic concepts required to understand the algorithm. Now, let's take a look at the code implementation. I am here in the code editor. I have this function reverse bits. It accepts a number n, which is a 32-bit integer, and we return int, which would be an integer with reverse bits. The first thing, I want to assign a variable results equals to 0. This is the variable I would return. Next, I want to iterate through all the bits of the number n. Since we know it's a 32-bit integer, so I can iterate 32 times. For underscore in range 32, we would iterate 32 times using this for loop. The first thing, I want to take out the bit. So I can say bit equals to n and 1. This would take out the least significant bit. After that, I want to add this to my result. So I can say result equals to result. I would left shift my result by 1, and I would or, which means add this bit over here. And once the result is the bit is added in the result, I can shift n by 1. So over here we are going to shift while we are adding the bit, and we are not going to shift after this. I would not write something like result equals to 1, this left shift 1, because if we do this, what if the 32th bit, which means the most significant bit, what if that is 1? If that is 1, I would still run this, which means I would lose that value. In the 32th time, I would lose the value, and that would give me an incorrect response. In this case, for the first iteration, our result bit would actually have two bits. One would be the 0 that I assigned. I don't care if this value is lost. I care if the value of n is lost. So what I would do is I would shift when I'm adding itself. What I could have done also is result equals to result shifting over here. This could have done. I'm combining these two and writing it like this. Let's return the result from this function. Let's run it. Let's submit it. So we have a solution.